On today's video, we're going to look at the cosecant and secant graphs. Our goal for this video is to sketch the secant and cosecant graphs using our knowledge of transformations, and to find the vertical asymptotes, the domain, the range of either the secant or the cosecant function. What is the process for graphing cosecant and secant graphs? Step 1, to find the equation of the corresponding reciprocal function. Now, what I mean by reciprocal function, recall that the cosecant function is reciprocal of the sine because cosecant theta equals 1 over sine, and the secant function is reciprocal of the cosine function because the secant of theta is equal to 1 over cosine of theta. Step 2, we're going to identify the key transformations of the reciprocal function. That's what we learned in the last video. We're going to figure out the period, the amplitude, the phase shift, the vertical shift, the midline, and the reflections of our sine or cosine graph. Then we're going to sketch that sine and cosine graph using our knowledge of transformations. We'll sketch this graph as a dashed line. And this is going to be our foundation of what's going to make our secant and cosecant graph, because we're going to use our sine or cosine graph to figure it out. How do we do that? Well, first thing we need to do is we're going to look at our sine graph or cosine graph, depending which one it is, our reciprocal functions graph, and determine everywhere the reciprocal functions graph touches the midline. Everywhere that the reciprocal graph touches the midline, the secant or cosecant graph will have what's called vertical asymptotes. To find the equation of the vertical asymptotes, we need to find the very first asymptote that is greater than or equal to 0. Since asymptotes repeat twice in a period, or repeat every period divided by 2 distance, the formula for the vertical asymptote, so that would be x is equal to first non-negative asymptote plus the distance between times by n. And n just stands for some integer, so n is an element of the integers. Each maximum point on the reciprocal function will then become a minimum point on the secant or cosecant function. This is done because of the reciprocal, because they are reciprocal functions of each other. So if you're looking at, say, the sine function, and anywhere that you have a maximum point on the sine function, that, from that maximum point, the graph curves down. Here on when we want to graph its reciprocal function, and reciprocal of the sine will be cosecant graph, we will flip up the U shape. And so now that point is at the bottom of the U, or the minimum point. Likewise, we'll do that for every minimum point on the reciprocal function will become a maximum point on the secant or cosecant function. Now that will result in having our entire graph of our secant or cosecant function. And then all that's left to do is to figure out the domain and range of that function. I'll teach this through example. So let's look at our first example. Given that y is equal to 2 secant of the quantity 1/2 x minus pi over 3, all of it minus 1, we're going to sketch this graph using transformation. So our first step, find the equation of the reciprocal function. Now remember, the reciprocal of secant is cosine. And so we would just replace our secant trig function with cosine trig function. So we get y is equal to 2 cosine of the quantity 1/2 x minus pi over 3 minus 1. Then I need to rewrite this reciprocal function in transformation form. And so since my coefficient of the x is not 1, we need to factor b out. And I get that y is equal to 2 cosine brackets of 1/2 parentheses x minus 2 pi over 3, close parentheses, close brackets, minus 1. And that is our reciprocal equation. Looking at this reciprocal equation, we need to figure out our transformations. So let's start by finding our period. Now recall, the period of the cosine graph is found by taking 2 pi divided by b. In this example, our b is 1/2. So since b is 1/2, we'll take 2 pi divided by 1/2. Flip and multiply that fraction, we end up with a period of 4 pi. Next, we're going to find our amplitude. Recall that amplitude is found by our a value, and in this case, a is 2. Since a is 2, our amplitude is also 2. Then we're going to find our phase shift. Our phase shift is found by our c value. In this case, it's minus the 2 pi over 3. And since it is negative, that tells us that our phase shift will go to the right, 2 pi over 3. Our midline is the equation y equals d. So d in this example is -1. So our midline is y equals -1. Now that we found our midline, we can also identify our vertical shift. So our vertical shift is also looking at D. D is -1, so that means we went down 1. And then to determine our reflection, we look and see if A is negative or if B is negative. Now in this example, neither A nor B is negative, so we would say that this example has no reflection. All right, to sketch this graph, we'll always start by sketching our midline. So remember, our midline is at y equals -1. And then we're going to use our transformations that we did from that last example, the transformation we just figured out. Notice that I've changed my tick marks. I'm counting by pi, so that takes care of my period. So I'm counting by pi, and I'm going to go up to 4 pi. And so we plot our point for our reciprocal function, and it would look like this. And then we sketch our graph. So here is our reciprocal functions graph. Now that we have our reciprocal functions graph, our next thing to do is we're ready to graph our original trig function graph. To do that, we need to figure out everywhere that this graph crosses the midline. So when the reciprocal function crosses midline, that's going to be equal to asymptotes of our original function. Now that we have our asymptotes, we identify all the minimum values on our reciprocal function. Those minimum values will become maximum values, so we flip over the u's. And then we identify all maximum values. These maximum values will now become minimum values. And taking away our reciprocal function, that leaves us our final graph. We have 3 things that we need to do now that we sketch the graph. We need to identify the equation of the asymptote. Then we need to find our domain and our range. So let's start by finding the equation of the asymptote. To find the equation of the asymptote, we first need to look at our graph and find the x value of the first non-negative asymptote. So looking at our graph, our first non-negative vertical asymptote would be this asymptote. Now we have a little problem. This doesn't fall perfectly on one of our tick marks, but we need to figure out the exact value of this point. To help us do that, we go back to our knowledge that we had a movement to the right of 2 pi over 3. So we look, since we're moving to the right, we're going to go back 1 tick mark, so that'd be at the pi. And then I'm going to take that pi and I'm going to add my right phase shift of 2 pi over 3. So I'm going to take pi plus 2 pi over 3. Now in order to add fractions, we need a common denominator, so I'm going to rewrite pi as 3 pi over 3. I'm going to add that to our 2 pi over 3 to give us equation of this first asymptote, which is x equals 5 pi over 3. So now I found my first non-negative asymptote. Next thing I need to do is find the distance between my asymptotes. Remember, for secant and cosecant, the distance between asymptotes, it will always be the period of the function divided by 2. So our period of this function was 4 pi. 4 pi divided by 2 gives us 2 pi, and so that's the distance between our asymptotes. Finally, we put these 2 bits of data together to write our equation of the asymptotes. Remember, the equation of the asymptote is found by taking the first non-negative asymptote plus the distance between times by n. So that would be x is equal to 5 pi over 3 plus 2n pi, and I'm going to find n as integer. And that's how you find the equation of the asymptote. Now that we know the equation of the asymptote, the next thing to do is find our domain. Let's go back to the graph. Now remember, domain is all the x values on the graph. Now this is a repeating function, although I'm only showing 2 periods. It keeps repeating this same u up, u down shape. And so our period will be our domain will be everywhere, all real numbers except for asymptotes, because notice the graph never crosses those asymptotes. So we need to identify that the asymptotes are not part of the domain, but everything else is. But our problem is, how do we write that? Our interval notation will not work because we're going to have infinite many intervals in which this happens, because we have these periods, these asymptotes that keep repeating infinitely many. And so what we do is we know our domain will be all real numbers except for our asymptotes. And so this is how we would write that using mathematical notation. That upside down A stands for, is our symbol for all, and the double bar R is our real number symbol. It's read for all real numbers where x is not equal to 5 pi over 3 plus 2n pi. So for all real numbers where x is not equal to your asymptotes is basically what you have. And that's how you find the domain of secant and cosecant graphs. Next, we're going to find our range. Again, we're going to go back to our graph of our function, and we're going to look for our y values. Notice that there's a middle part of this graph that is blank, that has no y values. And so we're going to have to break this up to two intervals using interval notation. We're going to find the domain of the bottom half of the graph, and then for our first interval, and the domain of the upper part of the graph for a second interval. So looking at the bottom part of the graph, I notice my graph starts at negative infinity and goes all the way up to a point at -3, and it includes the -3. So I would start my first part of my domain as parentheses, -3, negative infinity to -3 bracket. And then for the next half, my range is covered from the top part of this graph. And so I would say the range starts at 1 and goes up to infinity. So that would be union, bracket, 1 to infinity, parentheses. Okay, let's try a cosecant one. So y is equal to 1 minus 1/2 cosecant of the quantity 2x plus pi over 2. We'll sketch this graph using transformations. So first thing I want you to do is find your reciprocal function in transformation form. Cosecant is the reciprocal of the sine function. So I'm going to replace the cosecant with sine, and then I'm going to get this in transformation form. Notice that the d is written in the front, so I'm going to move the d to the back. And then also notice that my coefficient of x is not 1, so I need to factor that out, factor my b out. And this would be my equation for my reciprocal function. Y is equal to -1/2 sine, bracket of 2, parentheses, x plus pi over 4, close parentheses, close brackets, plus 1. So now that I have the reciprocal function, I'm going to identify my period, amplitude, phase shift, midline, vertical shift, and reflection for this sine graph. So period is 2 pi over b in this case. B is 2. So 2 pi divided by 2 will give us pi. And so our period is pi. Amplitude is determined by our a value, the absolute value of our a. And in this case, the absolute value of our a is 1/2. So our amplitude is 1/2. Then we're going to find our phase shift. Our phase shift is determined by our c value. Our c value here is pi over 4, which is positive, so that means we're going to go to the left, pi over 4. Our midline is y equals d, so then in this case, since d is 1, that would be y equals 1. Our vertical shift is moving up or down, and that's also determined by our d value. Since d is +1, our vertical shift is up 1. Last but not least, we're going to look at reflection. Remember, reflection is looking at your A and your B and determine if either one of those are negative. In this case, our A value is negative. So since A is negative, that gives us a reflection across the midline. All right, to sketch our graph, we're going to start by sketching the midline at 1. Notice that I've changed my tick marks to pi, counting by pi over 4, since my period of the sine function was pi, and took pi divided by 4, gives us to count by pi over 4. I also noticed because my amplitude was 1/2, I went ahead and changed my y-axis to count by 1/2 as well. Now I'm going to graph this sine function. So remember, sine starts on the midline. Traditionally, sine starts on the midline, above, on, below, on. But because of the reflection across the midline, where our pattern is now going to be on, below, on, above, on. And notice we have a left of pi over 4, which is exactly 1 tick mark. So every one of those tick marks, it's going to be moved to left 1. So that point at 0, 1 is now going to be back to negative pi over 4 and a height of 1 for my starting point. I'm going to graph 2 full periods of this graph. That's key. That's something that's different than what we did in the last section. Is our parent function needs to be our reciprocal function. We need to do the 2 full periods, not just 1 period. So there are all my points of my sine function. If you check and see, make sure you plotted those correctly. And so this is my reciprocal function, the sine function that corresponds to the given cosecant graph. Now that I have this, I'm going to use this blue graph to help me graph my actual cosecant function. First thing I do is notice every point in which this blue graph intersects our midline, which would be these 4 points here. Those points where the reciprocal function crosses the midline are equal to the asymptotes of our cosecant graph. So we have our asymptotes drawn. Then I'm going to identify every point on my reciprocal function that is a minimum, which would be these bottom 3 points. Every minimum on reciprocal function will come a maximum on the original function, or in this case, the cosecant function. So the u's going up now becomes u going down. And notice that the u's don't go down to approach those asymptotes on every side. So it curves down and approaches the asymptotes. Then identify the maximum points on my graph of my reciprocal function. And those maximum points will now become minimum points. And so we will have u's going up from them. And then I can sketch my final graph. My final graph is everything in orange. So I just do not include our midline and our sine function. We're not done though. Now that we found our cosecant function, we need to identify asymptote, our equation of our asymptotes, our domain, and our range. Let's start with the equation of the asymptote. Remember, to find the equation of asymptote, we need to find the x value for the first non-negative asymptote. So looking back at our graph, our first non-negative asymptote occurs here at pi over 4. Well, that's actually on a tick mark, so I don't have to do the algebra that we did last time, and I can just say that my first non-negative asymptote is pi over 4. Okay, next step is find the distance between our asymptotes. Remember, the distance between asymptotes is always equal to period divided by 2. So the period of this function was pi. Pi divided by 2 is just pi over 2. And so my final thing is to put that together to write the equation. The equation of our vertical asymptote is x equals our first non-negative asymptote plus the distance between times n. And so in this case, that'd be x is equal to pi over 4 plus n pi over 2, where n is an element of the integers. And we found our asymptote equation. Last but not least, we need to figure out our domain and range. So to find the domain, we look back at our graph. And remember, the domain will be all real numbers except for everywhere we have our vertical asymptotes. So it's all numbers except those vertical asymptotes. To write that out, we would say that all real numbers where x is not equal to pi over 4 plus n pi over 2. Then to find our domain and range, our range value is our y values. So we're going to find our smallest y value is negative infinity up to our maximum point of the lower half of the graph, which in this case would be 1/2, from negative infinity to 1/2, including the 1/2 in brackets. And then we're going to find the domain of the upper part of the graph. That upper part of the graph starts at 3/2 and goes up to infinity. So we'd say that's bracket 3/2 to infinity, close parentheses.